Good morning, students. In the last class, we discussed about the ionic product of water, pH of solution. In the ionic product of water, we have seen that the water undergo very feebly ionization, and when we are taking H2O is giving water H plus OH minus, okay, and applying law of chemical equilibrium, we got K equal to H plus into OH minus by H2O. Because H2O is undergo feebly ionization, okay, the concentration of undissociated water molecule remains constant. So K into H2O is equal to what? H plus and OH minus, and this one is called what? KW, the ionic product of water. Okay, and this ionic product of water KW at room temperature is found to be 1 into 10 power of minus 14 moles per liter. And we have seen that for a solution where the H plus ion concentration is equal to OH minus ion concentration, then H plus is equal to OH minus ion concentration is equal to square root of 10 power minus 14. So we got 10 power minus 7. So those solutions where the H plus ion concentration and OH minus ion concentrations are equal to 10 power minus 7 are known as a neutral solution. And those solutions where the H plus ion concentration is more than 10 power minus 7, that is 10 power minus 6 or minus 5 or minus 4, that are called what? Acidic solution. Okay. And the solutions where the OH minus ion concentration, okay, is more, okay, that are called what? Basic solution. Okay. But this method of expressing the concentration of H plus and OH minus ion concentration to determine the acidic or basic character of a solution has become difficult due to the very small values. That's why another concept of the pH introduced by Sorensen, okay, and that is called pH scale. pH is equal to minus logarithm of H plus ion concentration. Okay, so pH equal to minus log H plus. Okay, so accordingly we found that those solutions where the pH value is equal to 7 are called what? Neutral solutions. And for acidic solution the pH becomes less than 7, and for basic solution the pH becomes more than 7. But the sum of the pH and pOH of a solution is equal to 1,4,14. Because the ionic product of the water at room temperature is constant, that is 10 power of minus 14. So pKW came into what? 14, and pKW is equal to pH plus pOH. So for any solution the pH and pOH is equal to what? 14. And accordingly we solved some numerical basing on the pH of solution. We find out the pH of different concentration of acid, and also we find out the pH of different concentration of the bases. And also we calculated the pH of solutions where the concentration, the amount of substance dissolved per liter is given. That also we calculated applying the molarity concept. Now today we will discuss about hydrolysis of salt. First of all, what is salt? What is your salt? In the second class of this chapter, we discuss about your acids and bases. We discussed acids are those substances which give H plus ion, and base are those substances which can give your OH minus ion. We discussed different theories. Okay, according to our definition, acids are those substances which can furnish a H plus ion in aqueous solution, and base are those substances which furnish a OH minus ion in aqueous solution. Okay. Now, if I take an acid, suppose HCl, an acid, and a base, NaOH. So when this acid and base will react with each other, then we will get what? NaCl plus H2O. So this is what? This is the acid, and this is what? Base. This is the acid because it can give H plus ion, and this is the base because it can give OH minus ion. So now this acid and base are reacting to give what? This one is called what? Salt and water. And this reaction is called what? Neutralization reaction. What? Neutralization reaction. So acids and bases are reacting to give what? Salt and water. So salts are the substances produced by the neutralization of acid and base. And this salt we can take of different kind, like neutral salt, like acidic salt, and basic salt. So neutral salts are those salts which are formed by the complete neutralization of acid and base. Like this, our HCl and NaOH we have taken here. We are getting NaCl and H2O. So this is a neutral salt. Okay. So if I take NaCl, NaOH and HCl, I am getting what? NaCl and water. Here, this salt NaCl is produced by the complete neutralization of the acid and the base. So this is called what? The neutral salt. And sometimes, suppose you see, if I will take H2SO4, okay, plus NaOH, okay, I can get here NaHSO4 plus H2O. Okay, you will see I am getting NaHSO4 plus H2O. Here H2SO4 is a polybasic acid. That means H2SO4 can give you 2H plus SO4 minus. So that means it can give you 2 proton or 2H plus ion. So it's a dibasic acid. Okay, so this dibasic acid undergo partial neutralization to give what? NaHSO4, and this NaHSO4 can further undergo neutralization to give your Na2SO4. So here this NaHSO4 is the acidic salt. Okay, so this is what acidic salt. Okay. Similarly, if I take a polyacidic base like MgOH2 plus HCl, if I take, okay, MgOH2 plus HCl, it's a polyacidic base. So here I will get what? MgOH2Cl, okay, plus H2O. So here this MgOH2Cl is a what? Is a basic salt. Okay, it may undergo further neutralization to give a neutral salt. Okay, so so neutral salts are the salts produced by the complete neutralization of an acid and base. Acidic salts are the salts produced by the partial neutralization of a polybasic acid, and similarly the basic salts are produced by the partial neutralization of polyacidic bases. Okay. So these are about the salts and basic kinds. Now let us have about the hydrolysis of salt. Okay. Hydrolysis of salt. So, what is hydrolysis? It is the reverse of neutralization. Okay. See, when I am talking about your NaOH plus HCl, I am getting what NaCl plus H2O. You see, the base and the acid are reacting to give the salt and water. So this is called neutralization. And when this NaCl and water will again further react to, they will give what only NaOH and HCl. This is called what hydrolysis. Called what hydrolysis. Okay, so hydrolysis is the reverse of the neutralization. So actually, what happens in this hydrolysis? It is the interaction of a cation or an anion with the water. So where the OH bond is breaking. Okay, let us see. If I have A minus here plus HOH. So here this OH bond can break. Okay, and we can get what? We can get Ha plus OH minus, and this is called what? Anionic hydrolysis. Called what? Anionic hydrolysis. Similarly, if I have a B plus ion here plus HOH here, this OH can break, and I can get what is B plus OH minus will get what? BOH plus H plus. Okay, so this is called what? Cationic hydrolysis. Called what? Cationic hydrolysis. So hydrolysis is the interaction of a cation or an anion with the water, where the OH bond of the water is breaking, and we are getting the corresponding products. Okay, so here this anionic hydrolysis, this anion is interacting with the water, and this is producing the acid Ha and OH minus. And in this case, the cation B plus is interacting with the water to give what? The base. Okay, so this is called anionic hydrolysis, and this is called what? Cationic hydrolysis. Okay. Now, so let us take a salt and let us hydrolyze the salt. Okay. Suppose AB is the salt, AB is the salt, and AB react with water H2O. Okay, so salt react with your water, so we will get water HA acid plus BOH base. Here I can add HOH. Okay, HOH, H plus OH minus, and AB A plus B minus. This salt AB is related with what, water HOHO. So we are getting what, HA acid and the BOHO base. Okay. Now applying law of chemical equilibrium. Applying law of chemical equilibrium. What I can get? K is equal to HA into BOH by AB into H2O. Okay, and for this hydrolysis we are taking the water in excess. Okay, and we know water is in excess and it is a pure solvent. So the concentration of the H2O is practically taken as a constant. So what I can write? I can write K is constant into H2O is constant is equal to HA into BOH by A. So this is your constant. This is your constant. Okay. And this is also constant. This K is constant, and this the concentration of water here is also what, is also constant. So constant into constant, I can take another constant called what, the hydrolysis constant AHO, which is called what, HA into BOH divided by AB. Okay, that is what, concentration of acid into concentration of base by concentration of salt. So hydrolysis constant KHO is what, is equal to concentration of acid into concentration of base divided by your concentration of your salt. Okay. Now let us discuss about the. So this is the way how can you express the hydrolysis constant of a constant of hydrolysis of a particular salt. Okay. Now let us discuss about the how the different kind of salts are being hydrolyzed. Okay, we can have different kind of salts like a salt of strong acid, strong base, salt of weak acid, weak base, salt of strong acid, weak base, or salt of weak acid, strong base. And accordingly, the hydrolysis product are different. Okay. So hydrolysis of strong acid and strong base we will discuss. Then also we will discuss about the hydrolysis of strong weak acid and weak base. Okay. So hydrolysis of salt. Okay. Salt of strong acid and strong base. Okay. Let's see. If I take HCl, it's a what? It's a strong acid. It's a strong acid because it's your mineral acid. And if I have NaOH, the strong base. Okay. So strong acid HCl and strong base NaOH. So when these two will combine, I will get what? NaCl and water. So here NaCl is what? It's what? It's a salt of strong acid and strong base. Salt of strong acid and strong base. Now, when this NaCl will undergo hydrolysis, what is happening? Let us see. Okay. NaCl will give what? Na plus your Cl minus. Now H2O giving what no? H plus OH minus. So here in this case, what happens actually? We have Na plus Cl minus plus H2O we are getting. See, in this case, because this NaCl is salt of strong acid and strong base. So here NaCl is giving Na plus and Cl minus. Okay. Now the Cl minus is the conjugate base of the strong acid HCl. So we have HCl and the strong acid, and its conjugate base is Cl minus. So this Cl minus conjugate base is a weak base. So whenever an acid is a strong acid, its conjugate base must be weak. Similarly, for a strong base, its conjugate acid must be weak. Okay. So because HCl is a strong acid, so its conjugate base Cl minus is a weaker one. So it is not having the tendency to take away this H plus proton. Okay. So what happens here in this if you write down your Cl minus, okay, Cl minus plus if I take H2O, okay, I can say HCl, okay, your H plus HCl plus OH minus. This is not possible. This is not possible. That means this Cl minus cannot take proton from the H2O because the Cl minus is a very weak conjugate base. That means this product remains as such. Okay, so Na plus and Cl minus. How do we can say the Cl minus Cl do not undergo hydrolysis? Okay, so in this case, the pH of the solution remains 7. So it's what? It's neutral. So hydrolysis of salt of strong acid and strong base results a neutral solution. The pH becomes 7. In fact, practically this kind of salt do not undergo hydrolysis. Okay. Now, salt of your weak acid and weak base. Salt of weak acid and weak base. Okay, so let us see a weak acid. Suppose CH3COOH. It's a what? It's a weak acid. Acetic acid is an organic acid and is a weaker one. Okay. Similarly, if I take NH4OH, ammonium hydroxide is a what? It's a weak base. So when this weak acid and weak base are combining, and we are getting what? The CH3COONH4 plus H2O. So CH3COOH is what? It's what? It's a salt of. It's a salt of weak acid and weak base. Salt of weak acid and weak base. Now, when this salt will undergo hydrolysis, what will happen? You see, CH3COONH4 will give what? CH3COO minus plus NH4 plus and H2O giving what? OH minus plus H plus. So these two can combine and these two can combine. So here we will get what? The CH3COOH plus your NH4OH. That means here the CH3COOH is the weak acid, so its a conjugate base CH3CO minus is a stronger one, and it is having the tendency to accept to the proton. So it gives what CH3COOH. And again, because CH3COOH is a weak acid, it again undergo feebly ionized. Again, the NH4OH being a weak base, it's a conjugate acid NH4 plus. Okay, it's also this also can attack the OH minus ion to give your NH4OH. So because both these two are the weak one, CH3COOH and NH4OH, both are ionizing into a same extent. So same quantity of the H plus and OH minus ions are being absorbed by this species. So the resulting solution will not have more amount of H plus or more amount of OH minus. As a result, here the pH will be equal to what? 7, and the solution becomes what? Neutral. So salt of strong acid and strong base undergo hydrolysis to have a neutral solution, and also the salt of weak acid and weak base also undergo hydrolysis to have a neutral solution. Okay. Then you know salt of strong acid and weak base. Salt of strong acid and weak base. Okay. See, a strong acid, if I take HCl, it's a what? It's a strong acid. When I take NH4OH, it's a what? It's a weak base. Okay. So when this strong acid and weak base are combining, we are getting the salt NH4Cl. So NH4Cl is what? The salt of strong acid and a weak base. Okay. Now see, when I have this NH4Cl giving what? NH4 plus Cl minus, and H2O giving what? H plus OH minus. Okay. Now see, NH4OH is a weak base. Okay, so its conjugate part NH4 plus is a stronger one. So it gives what? The NH4OH. Okay, so this NH4 this is your NH4 plus HOH, your what? NH4OH plus H plus. That means because this ammonium hydroxide NH4OH is a weaker one, so its counterpart of NH4 plus is a stronger one. It readily takes away this OH minus ion, and because this OH minus ions are being taken by this NH4 plus, there is a deficiency, there is a decrease in concentration of this product side. So according to Lee Charteris principle, the reactions will go forward. So more and more H2O will dissociate, that will give what? More and more H ion and OH minus ion. Again this OH minus ion will be taken by the NH4 plus. Okay, but the H cannot be taken by the Cl minus because the Cl minus is the weakest conjugate base. So at any time if you see there will be an enhanced quantity of the H ion concentration. Okay, that means because that means the concentration of H ion will increase. Okay, so because the concentration of H ion is increasing, that means the pH value is decreasing and hence the solution is becoming acidic. Okay, so here what pH becomes what? Less than 7, though solution is what? Solution is what? Acidic. So the hydrolysis of salt of strong acid and weak base. Strong acid and weak base. Strong acid will give what? Acidic solution. Okay. Similarly, we can go for what? The hydrolysis of salt of weak acid and strong base. Okay. Salt of weak acid and strong base. Okay. See, for example, if I have CH3COOH, it's a what? It's a weak acid. And when it is reacting with a strong base, like for NaOH, strong base, it is giving what? CH3COONA plus H2O. So this is what? This is what salt of weak acid and strong base. Salt of weak acid and strong base. Now CH3COONA giving what? CH3COO minus plus what? Na plus. And H2O giving what? OH minus plus H plus. So here you see the CH3COOH is a weak acid, so it's a conjugate base of CH3CO minus is a stronger one. So it can readily take away the CH plus ion to give what? CH3COOH. But NaOH is a strong base, it again dissociates into OH minus, Na plus and OH minus. Right? Now, when the C3CO minus, because it's a strong conjugate base, it is taking away this proton. Okay? So there is a decrease in concentration of the product side of these reactions. So this decrease in concentration of this H plus ion in the product side will lead the reaction to go forward according to Lee's Charteris principle. Because the concentration of the product side is decreasing, so the reaction will go forward. So more and more amount of this OH minus ion will produce. So at any moment, if you see there is an increased amount of OH minus ion in this solution. Okay, so that means there is a that means what? there is a decrease of this H plus ion concentration. Accordingly, the pH value will be more than 7 and the resultant solution will be what, basic in nature. Okay, so here what will happen? pH will be what, more than 7. Okay, and our solution is what, basic or alkaline Okay, so here we will get what? CH3COOH plus what? OH minus. Okay, so salt of strong acid and strong base resulting a neutral solution. Salt of weak acid, weak base result a neutral solution. Whereas salt of strong acid and weak base result an acidic solution. And salt of strong base and weak acid results a basic solution. So this is about part of the hydrolysis of the salt. Okay. Next, see your solubility product. Solubility product. Okay. See, if you consider salt like an HCl, HCl is a sparingly soluble salt. Okay, they undergo very less ionization. Okay. So HCl giving what, Ag plus Cl minus, but most of the HCl will remain undissociated. So we can write like this. Okay, this HCl is a sparingly soluble salt. Okay, and giving what, the Ag plus and Cl minus ion. Okay, but most of these HCl will remain undissociated. Okay, so there will be an equilibrium. So what I can write here? Applying law of chemical equilibrium. Applying law of chemical equilibrium. We have K is equal to Ag plus into Cl minus by HCl soluble. Okay, or I can add K into HCl solid. Okay, is equal to Ag plus into Cl minus. Now here you see this K is constant and HCl solid, which is the undissociated molecule, its concentration is also constant. So constant into constant, we can take another constant called what? KSP is equal to what? Ag plus and the Cl minus. So here this KSP is called what? KSP is called what? Solubility product constant. Solubility product constant. Okay, so Ks is equal to Ag plus and Cl minus. Suppose we have a salt like AXBY, I can write what? XAY plus YBX minus. So here KSP is equal to AY plus power xo into bx minus power y. And this solubility product we are determining when the solution is saturated. Okay, so you know a solution to which more amount of solute can be added are called what? Unsaturated solution. And the solutions to which no more solute can be added at room temperature are called the saturated solution. So when we are going to prepare a solution at the saturated state, how many ions are there? Okay, their product is called what? Solubility product. So the product of concentration of the products or ions, the product of the concentration of the ions is raised to the power, okay, these are the powers equal to their stoichiometric coefficient as per the balanced chemical equation for a solute, for a electrolyte in its saturated solution is called what? Solubility is a constant called what? Solubility product constant. So this solubility product we are determining only when the solution is saturated. If we will consider any other concentration, that will be called what? Ionic product. So XBY will give you XAY plus YBX minus any concentration, any state of the solution except its saturated state. Okay, then this will be called what? Ionic product. If the solution is at saturated state, then this product will be what? Solubility product. Any other concentration is called what? Ionic product. Okay, so this is the difference between what? The solubility product and what? The ionic product. Okay. Now, suppose this salt, okay, AXBY is giving what? XAY plus YBX minus. Okay, and let S mole per liter is the solubility of the salt XBY. That means in 1 liter S mole of XBY is dissolving to form the saturated solution. Okay, so you will see 1 mole of XBY is giving what? X mole of AY plus and Y mole of BX minus. So here if S mole of XBY will dissolve, we will get what? S X mole of AY plus and S Y mole of BX minus. Because 1 mole is giving X, so S will give what? Sx. Okay, so here ASP is equal to what? AY plus power X into BX minus power Y. Okay, so here then I can write here KSP is equal to AY plus how much? Sx. So Sx power x. Bx minus how much? Sy. So Sy power y. So KSP is equal to x power x, s power x, s power y, y power y. So KSP is equal to x power x and y power y into s power x plus y. So in this way we can find out the solubility product constant for a sparingly soluble salt like on XBY. So this is the formula. So here x power x, so x is the coefficient of the AY plus ion and y is the coefficient of the BX minus ion. So x power x, y power x, y, and solubility s, b power x plus y. So using this expression we can find out the solubility product constant. Okay, and we will solve some numericals based on this formula of solubility product constant, and that we will continue in the next class. Okay, thank you.